Engineer, asante sana for hosting us.
Asante.
So now let's get into that conversation of the mixes and the grids. What is the difference out of the three?
Concrete actually is a mixture of several elements. We have cement, we have fine aggregate, which is normally sand in the case of our country here, but in other places we can have crushed stones. And then we have ballasts or coarse aggregates, which we normally call kokoto in our Kenyan situation. So these elements, they are mixed in certain ratios. These ratios, when they are mixed up, they give certain properties to the concrete. Therefore, this mixing is what we gives a grade or a class of concrete, depending on the mixes. The class simply means the strength acquired by this mix at the age of 28 days, a certain strength in terms of newtons per millimeter squared. It's called compressive strength. So after 28 days, it is deemed that a mix of concrete has acquired around more than 99% of its strength.
What recommendations do you give then for the different ratios, for the different scenarios?
So when we come to the issue of classifying concrete or grading concrete, we have a class of concrete, for example, from class 10 to even class 60. When you say a mix is ratios. The ratios of cement, sand, and ballast. When you say class, it is the amount of strength it acquires after 28 days. So for example, when we say mix 10, a mix 10, it is the ratio of 1 to 4 to 8, whereby 1 is cement, 4 is sand, and 8 is ballast. Now, when we say ratio, we mean that whatever you're using to measure these elements is the same unit. If it is a wheelbarrow, let the wheelbarrow be used to measure all the elements. Then that one gives a ratio. So that ratio of 1 to 4 to 8, at the age of 28 days, it gives you a ratio of 10 newtons per millimeter square.
All right. And do you have testing methods, to ensure that there's quality?
After mixing, there are samples which are taken in forms of cubes. A cube of 150 millimeter by 150 millimeter by 150 millimeter. So these cubes, after they have been taken, they are put in a curing state, whereby they are immersed in water. The sample is taken, then it is given a day to harden, then it is immersed in water for up to 28 days. Then from there, it is now taken to an equipment that is called a compressive strength testing machine, whereby it is compressed until it crushes. At the point of crushing, the loading versus the area of that cube is taken, and then you get now what you call a compressive strength of that particular cube. So that strength acquired at that particular time is what we say that that mix, we expect it at 28 days to have attained 10. So we have 10, 15, 20, 25, 30, 35, even up to 60. Depending on where are you going to use this concrete.
Water is also obviously a very big component in this. At what point does it come in?
It is the element that reacts with cement as a chemical reaction. This chemical reaction now produces something that is hardened. After it has reacted, it now produces the hard element. The cement and the water, when they are mixed, at the time they are mixed, they form a paste. This paste is the bonding element that bonds all these other aggregates together.
Okay. And we all know shortcuts.
Yes.
Negligence. It's unsaid, but it really is what it is. What are some of these shortcuts that people take when it comes to construction? And as an authority, how do you mitigate that?
The mistake that most of the construction workers do, they will use, when you say, for example, a ratio of 1 to 2 to 4, that is 1 cement, 2 sand, and 4 ballast. What a construction worker will do, he'll take 1 bag of cement and use wheelbarrow to measure these others. So he'll take 1 bag of cement, 2 wheelbarrows of sand, and 4 wheelbarrows of ballast. You see, you may find the wheelbarrow is double or twice the size of a bag of cement. So at the end of it all, when you come to the proper calculation of the ratio, you may find that he's doing 1 to 4 to 8, which is a very weak concrete. Now, the authority now comes in to mitigate in this manner. In case our team goes to the site and finds that the mix on the site is wanting, the owner is notified and even the engineer is notified about it. And if they become adamant, there is another arm of the government that normally does what you call building audits, the audit of building. That is the National Building Inspectorate. They are called upon to do an audit on that building, what you call a structural audit on that building. In case there is an incident like a collapse, the investigations which are carried out. These investigations which are carried out are to determine what happened and who was responsible. It has been found in most of the collapses that have happened, the professionals were not involved. I mean, structural engineers or architects were not involved in the execution of the works. And therefore, the owner, the developer of the works, took upon themselves to do the works the best way they know about it. Or they went and got a fundi who told them, I did those works there, I did those works there, so I know what I'm doing. But in reality, they are not proficient to do what they are doing.
Fantastic. Asante sana Engineer Were for that valuable information.
Karibu sana.
Kila laheri. All right, let me take a break, but when we come back, tunaenda Eastleigh shopping ya curtains.